Welcome to Exploring the Pentatope, a journey into 4 dimensions. In this video, we will delve into the fascinating world of 4-dimensional geometry, exploring the structure and properties of the Pentatope. Get ready to expand your understanding of dimensions beyond the familiar 3. Let's begin this journey into the 4th dimension. Imagine a world beyond our comprehension. A world where shapes twist and turn in ways our minds struggle to grasp. This is the realm of higher dimensions, a place where our everyday intuition about space crumbles. It's a place where the familiar rules of geometry are bent and a new kind of spatial reasoning takes hold. It's a place where we encounter objects like the Pentatope. The Pentatope is a 4-dimensional object, a mathematical construct that exists beyond our 3-dimensional perception. Just as a cube transcends the flatness of a square, the Pentatope transcends the 3 dimensions we experience. To truly understand it, we must stretch our minds and embark on a journey into the realm of hyperspace. This journey isn't just for mathematicians, it's for anyone who has ever looked up at the night sky and wondered about the true nature of reality. It's for anyone who has ever pondered the hidden dimensions that might lie just beyond our perception. So let's dive into the fascinating world of the Pentatope, a world where imagination meets mathematics and where the boundaries of our understanding are pushed to their limits. Let's unravel the mysteries of this 4-dimensional marvel and explore the profound implications it holds for our understanding of the universe. The Pentatope, also known as a 5-cell or a hyperpyramid, belongs to a class of geometric shapes called polytopes. These are the higher dimensional analogues of polygons and polyhedra. Just as a cube is a 3-dimensional polyhedron bounded by squares, the Pentatope is a 4-dimensional polytope bounded by 5 tetrahedra. To understand the Pentatope, we must first acknowledge the limitations of our perception. We are 3-dimensional beings confined to a 3-dimensional world. Our brains are wired to process length, width and height, but the 4th dimension remains elusive. Imagine a 2-dimensional being living on a flat plane. It can perceive length and width, but has no concept of height. Now imagine a sphere passing through this plane. The 2-dimensional being would only see a series of circles, changing in size as the sphere intersects its plane. Similarly, when we try to visualize the Pentatope, we are like the 2-dimensional being trying to comprehend the sphere. We see only projections and shadows, glimpses of a reality that exists beyond our sensory experience. Yet, through mathematics, we can unlock the secrets of these higher dimensions and begin to appreciate their elegance and complexity. Let's break down the structure of the Pentatope. This 4-dimensional object is composed of 5 vertices. These are the corner points of the Pentatope, analogous to the corners of a square or a cube. 10 edges, these are the lines connecting the vertices, similar to the edges of a cube. 10 faces, each face of a Pentatope is a tetrahedron, a 3-dimensional pyramid with 4 triangular faces. 5 cells, these are the 3-dimensional boundaries of the Pentatope, each one being a tetrahedron. Think of the Pentatope as a hyperpyramid. In a 3-dimensional pyramid, the base is a polygon, and the sides are triangles that meet at a point called the apex. Similarly, in a Pentatope, the base is a tetrahedron, and the 4 sides are also tetrahedra that meet at a 5th point in the 4th dimension. To visualize this, imagine a point hovering above a tetrahedron. Now, connect each vertex of the tetrahedron to this point with an edge. You've just constructed a Pentatope, albeit a very simplified representation of one. Remember, the true Pentatope exists in 4 dimensions, and our 3-dimensional minds can only grasp its shadow. Visualizing 4-dimensional objects like the Pentatope can be challenging, but we can use analogies and projections to aid our understanding. One way is to consider the relationship between a cube and its 2-dimensional shadow. Imagine a light source shining on a cube. The shadow cast by the cube onto a flat surface would be a 2-dimensional shape, perhaps a hexagon or a square depending on the orientation. Similarly, a Pentatope, when projected into 3 dimensions, creates a 3-dimensional shadow. This 3-dimensional projection can take on different forms, but one common one is a double tetrahedron, where 2 tetrahedra are intertwined in a specific way. Another way to visualize the Pentatope is to imagine unfolding it, just like you can unfold a cube into a flat 2-dimensional shape. The unfolded Pentatope would consist of 5 tetrahedra connected in a specific pattern. Remember, these projections and unfoldings are merely representations. The true pentatope exists in 4 dimensions, and its essence cannot be fully captured in our 3-dimensional world. Section 5. Shadows and projections. The concept of shadows and projections is crucial to understanding higher dimensional objects. Just as a 3-dimensional object casts a 2-dimensional shadow, a 4-dimensional object casts a 3-dimensional shadow. Imagine a hypercube, also known as a tesseract, passing through a flat plane. A 2-dimensional being on that plane would witness a series of squares appearing, changing shape, merging and disappearing. This is analogous to how we perceive the pentatope. We see its 3-dimensional slices as it intersects our 3-dimensional space. These slices can appear as tetrahedra, pyramids, or even more complex shapes, depending on the orientation of the pentatope. The study of these projections is not merely a mathematical curiosity, it has profound implications for physics, particularly in the realm of string theory. String theory suggests that our universe may have extraspatial dimensions curled up at incredibly small scales. These extra dimensions are hidden from our senses, but their effects could be observed indirectly through the interactions of subatomic particles. By studying the projections of higher dimensional objects, we gain insights into the possible geometry of these hidden dimensions. Section 6. A symphony of symmetries. The pentatope is a highly symmetrical object, exhibiting a level of symmetry that surpasses even that of the cube. In geometry, symmetry refers to the ability of an object to be transformed in certain ways while still maintaining its original shape. The pentatope possesses a remarkable property called self-duality. This means that its structure is identical to its dual polytope. In simpler terms, if you were to connect the centers of each cell of a pentatope, you would create another, smaller pentatope. This self-duality is a testament to the pentatope's elegant and harmonious structure. It's like a perfectly balanced equation where each part reflects and complements the whole. The study of symmetry is essential in mathematics and physics. It provides a powerful tool for understanding the structure of objects and the laws that govern their behavior. The high degree of symmetry exhibited by the pentatope makes it a fascinating object of study for mathematicians and physicists alike. In the world of higher dimensions, the pentatope plays a fundamental role. It's one of the 6 regular convex polytopes that exist in 4-dimensional space, analogous to the 5 platonic solids in 3 dimensions. These regular polytopes are the building blocks of hyperspace, representing the most symmetrical and elegant shapes in higher dimensions. Just as the platonic solids can be used to construct more complex 3-dimensional structures, the regular 4-dimensional polytopes can be combined to create intricate hyperspatial tessellations. Imagine a world built not of cubes but of pentatopes tessellating to fill 4-dimensional space. It's a mind-boggling concept, but one that highlights the potential richness and complexity of higher dimensions. The study of these higher dimensional building blocks is not merely an abstract pursuit. It has important applications in fields such as computer graphics, data analysis, and even cosmology. The pentatope has a close relationship with another fascinating 4-dimensional object, the tesseract, also known as a hypercube. While the pentatope is a 4-dimensional pyramid, the tesseract is a 4-dimensional cube. Imagine a cube with another cube growing out of each of its 6 faces. That's a simplified way to picture a tesseract. Just like a cube is bounded by squares, a tesseract is bounded by cubes. The tesseract and the pentatope are 2 of the most well-known 4-dimensional objects, and they share many interesting properties. Both exhibit a high degree of symmetry and can be projected into 3 dimensions in fascinating ways. Understanding the relationship between these 2 shapes can deepen our intuition about 4-dimensional space. They are like 2 sides of the same coin, offering different perspectives on the same underlying geometry. The exploration of higher dimensions, including the study of the pentatope, is not just a mathematical curiosity. It has profound implications for our understanding of the universe. Einstein's theory of general relativity, which describes the nature of gravity, tells us that space-time is a 4-dimensional fabric that can be warped and curved by mass and energy. This warping of space-time is what we perceive as gravity. In string theory, a leading candidate for a theory of everything, the universe is thought to have extra spatial dimensions curled up at incredibly small scales. These extra dimensions are hidden from our everyday experience, but could hold the key to unifying gravity with the other fundamental forces of nature. By studying higher dimensional objects like the Pentatope, we develop the mathematical tools and intuition needed to explore these mind-bending concepts.
The journey into the world of the Pentatope is a journey into the heart of geometry, a journey that leads us to question the very nature of space and dimension. It's a journey that reminds us that our perception of the world is limited and that there are realms of existence beyond our immediate comprehension. The Pentatope, with its elegant symmetry and mind-bending properties, serves as a symbol of the infinite tapestry of dimensions that may exist beyond our own. It's a reminder that the universe is a place of endless wonder and mystery, a place where mathematics and imagination combine to reveal the hidden depths of reality. As we continue to explore the cosmos and delve deeper into the fundamental laws of nature, the study of higher dimensions will undoubtedly play an increasingly important role. And who knows what other strange and beautiful objects await our discovery in the vast expanse of hyperspace.
In conclusion, we've journeyed through the fascinating world of the fourth dimension and the Pentatope. The Pentatope, with its elegant symmetry and mind-bending properties, serves as a symbol of the infinite tapestry of dimensions that may exist beyond our own. It's a reminder that the universe is a place of endless wonder and mystery, a place where mathematics and imagination combine to reveal the hidden depths of reality. We'd love to hear your thoughts and any revelations you had in the comments below. What aspects of the Pentatope intrigued you the most? Which part of our journey sparked your imagination? Don't forget to like and subscribe for more intriguing explorations into the mysteries of the universe. As we continue to explore the cosmos and delve deeper into the fundamental laws of nature, the study of higher dimensions will undoubtedly play an increasingly important role. And who knows what other strange and beautiful objects await our discovery in the vast expanse of hyperspace. Stay curious, and until next time, keep your mind open to the wonders of the universe.